Alright, this is lesson 41. We're talking about functions. Okay? First thing we need to know is the definition of a function. A function is a mathematical rule, should say that, a mathematical rule that identifies a relationship between two sets of numbers. Okay? And this is key right here. In a function, there is only one output for every input. Meaning, if I put something in to the function, I should only be able to get one thing out. Okay, not more than one thing. If I can get more than one thing out, then it's not a function. Okay, so let's look at what this means. So for example, the relationship between the perimeter of a square and the length of its sides is a function. Okay, because the perimeter of a square is equal to 4 times each one of its sides. Okay, so for example, this right here is called an input-output table. So when your objective says to graph or to evaluate functions and graph functions using an input-output table, that's what an input-output table looks like. Okay, you've got whatever you're putting in this case the length of our sides. Here's the function. It says the perimeter is equal to 4 times each side, and what you're getting out is the perimeter. So for example, if I put in a side length of 1, and that means the perimeter is equal to 4 times my side length, which is 1. So the perimeter is 4. Okay? And likewise, if I put in 2, then the perimeter is equal to 4 times 2, which is 8. Okay, if I have a side length of 3, doesn't matter what it is, 3 inches, 3 centimeters for a square, then the perimeter is equal to 4 times 3, which is 12. And we'll do one more. If I were to put in 4, okay, if I have a side length of 4, then the perimeter is equal to 4 times 4, which is 16. So notice, up here it says that in a function there is only one output for every input. So when I put in the number 1, the only thing I can possibly get out is the number 4. When I put in the number 2, the only thing I can possibly get out is the number 8. When I put in 3, I can only get 12. And when I put in 4, I can only get 16. So this is a function. Okay? The relationship between the sides of a square and its perimeter is a function. Okay? Because for every input, every one of these numbers, there's only one possible number that goes over here. Alright? So this right here is called a function. Now let's look at one that would not be a function. Okay? Well, if I have, let's say that I have x is equal to y squared. Okay, and I've got some x's and I've got some y's over here. Okay, so let's say I put in 1 for an x. Okay, and I want to know 1 equals y squared. So I want to know what number times itself gives me 1. Well, 1 is one answer, but I can also get 1 by taking 1 times, or negative 1 times negative 1. So if I put in 1 and say 1 equals what squared, and I can also put in negative 1. So the number 1 has two different outputs. It can be 1 or negative 1. Okay? Likewise, let's say I put in 4 for an input. And I want to know 4 equals what number squared? Well, one answer is 2, but another answer that I can get is negative 2. Okay? So the input 4 has more than one output. So this over here is not a function. Because for one input, there is more than one output. Okay? So that's what we mean when we say for every input, there's only one output. So this over here, not a function. Alright, let's move on. Okay, so objective 1 is to use an input-output table to graph functions. So I just showed you what an input-output table looks like. Okay? So now we're going to use it to make graphs of functions. And here's our first example. It says the perimeter of an equilateral triangle is 3 times the length of one of its sides. So part A is to write an equation that expresses this relationship. So it says to use P for perimeter and side for, or S for side length. So for part A, I know that the perimeter of an equilateral triangle is equal to 3 times the length of a side. Okay, we can say the length of a side. So now I'm going to use the variables they gave us to represent these. So instead of using the word perimeter, I'm going to just use the letter P. Well, I still got the letter or the number 3 times the length of a side, and for side length they told me to use the letter S. So perimeter equals 3 times S, or we could just write it like this. Okay? So there is our function. Perimeter equals 3S. Okay? On the next slide, we're going to choose 4 different side lengths. We're going to do part B. Okay? It says choose 4 different side lengths and make a function table that shows the side lengths and the perimeters of equilateral triangles. So let's move on to the next slide. Alright, so here I've got an input-output table set up again. Notice this one looks a little different. What I've added over here is a column to help us graph, okay? And we'll talk about what that means as we go here. So we got our input value, our side lengths. We've got our function right here, perimeter equals 3 times the side lengths. And we got our output. When we put in a side length, we should get a perimeter out. Okay, and we'll talk about what this one over here means in just a second. So let's pick some side lengths. Now, it doesn't make sense to pick negative numbers for sides, so we're going to use positive numbers. So I'm going to pick, for this case, and the easier the numbers, the better. So we'll do triangles that have side length of 1. Could be, again, 1 inch, 1 centimeter, whatever it is. 2, 3, and 4 to make it easier on ourselves. Okay, now when we plug in here, we're just going to replace this letter S, our input letter, with the number we picked. So instead of saying perimeter equals 3 times S, I'm going to say the perimeter equals 3 times my S value for this row, which is 1. Okay? Then over here, I'm going to actually tell what P is. So if P equals 3 times 1, then P has to be 3, because 3 times 1 is 3. Then here, we're going to write a coordinate, an ordered pair. And what these coordinates are going to do is help us to graph. So in this case, our S is first and our P is second because our input always comes first. That's always our first value in our ordered pair. And our P is our second value. A lot of times you'll see the letters X and Y associated with these. Okay, same thing here. You'll see an X for the input and a Y for the output. Okay, in this case they want us to use S and P. So I'm going to write parentheses, and my S value is 1 and my P value is 3. Okay, so same thing here. On the second row, I'm going to plug in the number 2 for my S value. So I'm going to say the perimeter, when the side length is 2, is equal to 3 times 2. Well, 3 times 2 is 6. And then my ordered pair is my S value of 2 and my P value of 6. Next row, our perimeter is equal to 3 times 3, which is 9. So I get 3 and 9 as my ordered pair. And the last one, perimeter equals 3 times 4. Again, notice here, my S values are the ones that I used over here as well. So that's where these numbers come from. And 3 times 4 is 12. So I get an S value of 4 that goes with the P value of 12. So this is how I'm going to fill out an input-output table. Okay, every time I ever fill one out. So I'm going to have some inputs that I choose. They're not always going to be the same. We'll talk about when to change those. Then in the middle here, I'm going to have showing my work for plugging the inputs into the function. So my output variable always stays the same as this over here. And I just plug in all my inputs to the function I have. Then I'm actually going to solve for the output. So again, we did 3 times 1 to get 3, 3 times 2 to get 6, and so on. And then my input value and my output value will go in ordered pair form. And the reason for that is because these are the 4 points that I'm going to graph. Okay, so we plotted points before. These are the points we're going to use to make our graph. Now, this was part B. Okay, part C is on the next slide. So we're going to actually make our graph on the next slide. So let's go ahead and go on to that. So I've rewritten my S and P values right here. This was the last column of our table, because this, again, is what we're going to use to graph. Alright, so something to notice here is first thing we need to do is name our axes. Okay, our input value is always going to be on this horizontal axis. Okay, so this is going to be my S-axis. And my output value is always going to be the up and down one. So that's my P-axis here. Alright, well, something to notice. Let's figure out how many squares we have. First of all, this right here is the origin. That's 0, 0. Okay, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares along this way. Okay, so this goes from 0 to positive 10. Well, if I look at my inputs, that's plenty for these because my inputs only go up to 4. Now on this side, we go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We also have 10 spaces going this way. And that's a problem with these ones because these values go up to 12. So I can't make these ones worth 1, 2, 3, can't number by ones. So what I need to do is write down what I'm going to number by. I'm going to number this axis by 2. So I'm going to have 2, 4, 6, 8, 10, 12, 14, 16, 18, all the way up to 20. Okay? And this axis is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay? Well, now I'm going to plot my first ordered pair. My first ordered pair has an S value of 1, so I'm going to start at the origin and go over to 1 with my S value. And then it goes up 3. Well, 3, if I'm counting by 2s, here's 2, and the next line is 4. So 3 is going to be about halfway in between those. So this point's going to fall right about in the middle of those. Okay? You have to excuse me on the iPad here. When I'm graphing these, it's kind of hard to tell. So again, this point should be about in the middle of this line right here. Then the next point is 2, 6. So I'm going to go over to 2 on my S-axis and count up to 6 on the P-axis. So again, it's 2, 4, 6, so it's going to fall right there. So I'm going to put a dot right on those cross lines there. My next one is 3, 9, so that's over 3 on this axis, and up 9. Again, 9 is going to fall in between the 10 and 8 lines. Oops, so it's going to go about right there. Okay? And then we're going to go to 4 and 12, which will go about right there. Now if I notice, when I look at these lines, okay, most of our functions we're going to graph, now most of them are going to be called linear functions, which means they make a straight line. So what I need to do now is connect the dots. And I'm going to start in my 0, 0 spot right here, and I'm just going to connect a straight line that goes through these dots and goes past them. Alright, you guys need to use a ruler, use a straight edge. I don't have one on my iPad, but you should always be using a ruler to graph your lines. And yes, Mr. Ayers can tell when you don't use a ruler. If your lines are crooked or they're wavy, okay, then I'll be able to tell that. So you'll need to make sure you use a straight edge every single time. Okay, so Mr. Ayers is going to connect these dots. And notice, I drew my line out past the dots I had, and I'm going to put an arrow on the end. Now normally I would put arrows on both ends to represent it's a line. However, in this case with perimeter, I can't have side lengths that are like negative numbers, so I couldn't have a side be -1 centimeters or -3 centimeters out here. Okay, so my line can't go past 0 for this real world example because we can't use negative numbers on it. But it could keep going out this way. Okay, I could have more lengths out here, possibly. Okay, like 6 and 18 would be another one that would go out here. Notice how that's on my line. Okay, so I have to put an arrow going out the positive direction. And that's how we graph lines. We're going to plot the points that we got in our input-output table and connect them to make a straight line with arrows on it. Alright, so let's go on to another example.